Hello. Here we want to solve some certain inequalities, and the very first inequality we'll be looking at is this inequality. It says x squared plus 3x minus 10 less than 0. Now all we are told to do in this question is we are told to find the values of x for which this quadratic function here is less than 0. Now normally there are different ways by which you can solve this. You could either graph the quadratic function, and then from the graph of the quadratic function you could see the range of values of x that satisfies this inequality. But then there is another way by which you can go about finding the range of values of x that satisfies this quadratic inequality. So, and I think is kind of quicker. So let me go ahead by telling you the steps involved. So the very first step you want to do, which I'm going to call step 1, is the first thing is you solve the quadratic equation itself. You solve it as an equation, not as an equality. Now that is, you want to solve. So you want to solve x squared plus 3x minus 10 equals 0. So you want to solve this. Now when you factorize x squared plus 3x minus 10, what you would obtain is x minus 2 into x plus 5. So this is what you obtain, equals 0. And then when two things multiply and you obtain 0, so this implies that either of them is equal to 0. That is, when you solve this, it implies either x minus 2 equals 0 or x plus 5 equals 0. And when you solve this, you obtain x equals 2 or x equals negative 5. So normally your number line, you recall the number line, you have something like this on your number line, and then if this is your number line, then maybe here is going to be your negative 5, which is this, and then your 2 is going to be somewhere around here. So we're going to use the number line as a paradigm in helping us to find the range of values of x that satisfies this quadratic inequality. So let's see how we go about that. So the next thing I'm going to do, which I'm going to call step 2, is I'm going to draw a table. Now corresponding to this number line, you have, so let's say we have so let's draw it here to make it clearer. So this is 5, and then this is this here. So you draw a line. Now for 2, I'm going to write 2 here. So let's write let me write 2 here, and then this is negative 5, and then I'm going to draw another line here. So this is going to represent the end of the negative values, which I'm going to call negative infinity here, and then here is going to be for positive infinity. Now on factorizing the quadratic function, what we obtained this. So we'll write x negative 2, write x plus 5, and then we have the product, which is x negative 2 into x plus 5. So let's make it look nicer. Yeah. So what we want to do is we want to find which range of values of x do we have, or do we obtain the product of these two expressions here having a negative number. So what we mean is, when x falls in this range, do we obtain a negative number here? Because that's what it tells us to check. When x falls in this range between negative 5 and 2, do we obtain a negative number here? When x falls between 2 and positive infinity, do we obtain a negative number here? So we want to know which of the range of values, these three ranges here, for which of them satisfies this quadratic inequality. That is exactly what we want to check. So to do that, you could pick any number between negative infinity and negative 5. So I'm going to pick negative 2. Let me pick let's say negative 6. So that's going to be, so I'm using negative 6. It lies between negative 5 and negative infinity. So negative 6 minus 2, that's negative 8. So I obtain a negative number here. Negative 6 plus 5, that's a negative number, and then what we have here is the product of the two of them, that is x minus 2, x plus 5. The product of their signs, as negative times negative, we obtain a positive number. So similarly here, you could pick any number between negative 5 and 2. So I'm going to pick 0. So when you substitute 0 here, 0 minus 2, that is negative 2, that's a negative number. When you come here, 0 plus 5, that is positive. And when you multiply, that's the product. When you multiply them, the negative times positive, that's a negative number. But when you come here, you pick any number between 2 and infinity. So let's pick 4. When you pick 4, when you substitute value of 4 here, 4 negative 2, you have 2. That's a positive number. 4 plus 5, you have 9. That's a positive number. And then positive times positive, you obtain positive. Then that brings us to the question here. The question says we should find the range of values of x for which this is less than 0, that is for which we have a negative number. And then what you observe is it is only here that we have a negative number. So that implies that the range of values of x for which the product here is going to be a negative number is the range negative 5 to 2, excluding negative 5 and 2, because we know negative 5 and 2, they are the zeros of the polynomial. That is, when you substitute negative 5 or you substitute 2 into the quadratic function, you would obtain 0. So we need to exclude negative 5 and 2 from the domain. So in other words, the solution set, that is the solution set of this quadratic inequality is going to be the set of all real numbers that lies between negative 5 and negative 5 and 2, as we can see here, negative 5 and 2. Alright, let's look at one more example just to ground understanding so that we understand the whole picture very well. So let's see another example. Say you're told to solve x squared plus x greater than or equals to 12. Now, how do you solve this? So like we said before, the very first thing you want to do is you want to solve the equation first. So the first step you want to do is you solve the equation. So you assume that you do not have any inequality sign here, assuming you have an equality sign. So that you want to solve x squared plus x equals 12. Now to solve this is a quadratic equation, so I need to bring 12 to this side. So we obtain x squared plus x minus 12 equals 0. And then to solve this quadratic equation, we first factorize this quadratic expression. And when you factorize this, you obtain x negative 3 into x plus 4. X plus 4 equals 0. So this is what you obtain when you factorize this. And then this implies that either x equals 3 or x equals negative 4. So this is what we have. Now, to solve this quadratic inequality, the next step you do is you draw a table. And I said to draw the table, we said it's like you have negative 4. So you remember your number line. This is like your negative 4 here, and this is your 3 here. So this and these are the zeros of the quadratic equation here. So now to implement the technique which I used above, so all we need to do is just draw a table. So my line doesn't look fine there. So let's say this is negative 4, and then this is 3 here. So let's call this part positive infinity, and we'll call the end here negative infinity, just like here it sounds here. This is something like this. So we already have a paradigm here, and then what we have here as the factors, we'll write it here x negative 3, and then we have x plus 4. And then the product, which is x negative 3 x plus 4, that is what we have. So what we want to check is the range of values for which we are going to have a positive number. It says greater than or equals to. So this time around, the end points of any interval we are going to be choosing would be included because of the equality sign that we have there. So we're going to check for here, or here. So here we pick any number. You pick any number between negative infinity and negative 4. So let's pick negative 6. So when we substitute negative 6 into here, negative 6 minus 3, that's negative 9, which is negative. Negative 6 plus 4, that's negative 2, which is negative. And then a product, negative times negative, that is positive. Similarly here, you could pick 0 is a number between negative 4 and 3. Now 0 minus 3, that is negative. Similarly here you have positive, and then negative times positive, that is negative. And then here between 3 and infinity you can pick 6. So when you substitute 6 into here, 6 negative 3, that is 3, that's positive. 6 plus 4, that's 10, that's a positive number, and then the product is positive. And then what we are told to check is, we are told to check for which of the range of values of x. Now we have 3 ranges here, 1, 2 and 3. Now for which range do we have a positive, it is greater than or equals to 0, a positive value? And then you observe that this range and this range are the ones that satisfies the quadratic inequality. And what does this range say? It says from negative infinity to negative 4. So this time around we include the endpoint because we have an equality sign here, and then similarly we have 3 infinity here. So therefore the solution this time around, the solution set is going to be x set of all real numbers such that x satisfies this condition here, that is you could say x less than or equal to negative 4 or x greater than or equal to 3. So that is going to give you the solution to the quadratic inequality, and then that should give you an overview of how to solve quadratic inequalities. If you do have any question, you could post it in the comments below. Thank you for watching.